All right, we have some examples and non-examples of parallelograms. Can you name the parallelograms? Okay, so let's look at A. A is a quadrilateral. It's definitely a parallelogram. How about B? Yep, B is a rectangle. It's a quadrilateral and it's a parallelogram because a parallelogram has to have opposite sides parallel. Your square is also a parallelogram. Now let's look at D. D has 4 segments, but they're not opposite and parallel. It is not a parallelogram. E has 1, 2, 3, 4, 5, 6 sides. It is a hexagon. F also is a quadrilateral. It is a trapezoid because it has one set of parallel opposite sides. So it's not a parallelogram. It is a, I'm going to call it a trap for a trapezoid. And there you have it. When looking at parallelograms, it's very important to remember that when you find the height, it must be perpendicular to the base. So we're going to look at some examples here and see which drawings are labeled correctly. So if you look at drawing A, they chose the base right here, base, and the height is right here. So you see that it does indeed form a perpendicular corner there. B, we have a parallelogram, but it looks like they chose this one for the base. And then is the height perpendicular? No, it is at an acute angle here. It is not perpendicular, so it is not drawn correctly. C, they extended the base. They chose this as the base, but we drew an extension line and then the height to the top of the opposite. Okay, so the height is indeed perpendicular to the base. So this one is drawn correctly. Letter D, that parallelogram, the base was chosen here, and then the height, yes, is perpendicular, straight up, across, connecting those two parallel lines. See, there's your parallelogram. And when we connect those two lines between the parallelogram, the parallel lines, it forms a perpendicular. Notice it forms a square in the corner. That's what a perpendicular line is. So that one is correct. And then E, they chose that as your base, but notice the height. Is that perpendicular? See that slanted? See it slanted from the base? That is not perpendicular. Find the area of each parallelogram. All right, we have 4 examples of parallelograms. The first one, letter A, is a rectangle. The first thing we want to do is find a base and a height. So let's look at A, and I like to take and count off my squares. I have 4 for my base. Now I'm going to find the height. The height has to be perpendicular. Rectangles are really great because they're kind of easy. 1, 2, 3, 4, 5, 6 is my height. And then it's 4 times 6 is 24. So the area of that one would be 24. B is a parallelogram that is not a rectangle. So we're going to have to find a perpendicular height. Let's first find our base. 1, 2, 3, 4, 5. I see there are 5 in my base. So we count how much of the square is covered and we see 5. Now let's find the height. Remember, the height has to be perpendicular. So you do not want to use that line or that line. You're not going to use those slanted lines. You're going to go straight up between the 2 parallel lines. So you have these parallelogram has parallel lines. We're going straight up. So we're going to count 1, 2, 3. So my height is 3. Now to find the area, I simply multiply 5 times 3 is 15. So the area of B is 15. C, we want to find our base, same thing. The base, you want to have a line that is on a line, not the slanted line for your base. We have 1, 2. Now to find the height, we want to go from this line. So I'm going to extend this line coming this way so that I can see how high it goes. See, the height is going to be, has to be perpendicular. So I'm going to count 1, 2, 3. So my height was 3, my base was 2. 2 times 3 is 6. So C is 6. D, same thing. We're going to find a base that is along the square line. So we're not going to use these two as bases because they're slanted. So let's use this as our base and let's count 1, 2, 3, 4. So our base is 4. Now let's find the height. We cannot use the slanted line. Let's use the perpendicular height between our two parallel lines. These are my parallel lines, so I'm counting between them. 1, 2. My height is 2. 4 times 2 is 8. So that parallelogram's area is 8. And there you have it. And here we have two more examples of the height of a parallelogram. This is very important that we want to identify the base. And notice that the height is the shortest distance from the base. So if this is our base, the height is the shortest distance from the base to the opposite side, and it has to be perpendicular. And over here we can find the base on, notice this line is our, what I call the slanted line, base 2, but the height then has to be perpendicular, and notice it goes to the opposite side, forming a perpendicular angle between the base and the height. Both of these are correct drawings of showing the base and the height of a parallelogram. All right, now let's do a little bit of practice with finding the area. Let's look at diagram A. We see a rectangle. I can look at it and count the squares and see the area is 8. But let's say we're going to use our formula, base times height. And let's find our base. Count 1, 2, 3, 4. So your base is 4. The height is perpendicular. We see it is 2. 4 times 2, 8 square units. B, we want to find our base. A little harder to see the area by eyeballing it, so we're going to want to find your base. 1, 2, 3, 4, 5. Your base is 5. Now, to find the height, we're not going to use our slanted line. We're going to go up, count 1, 2. We see our height is 2. 5 times 2 is 10, so that area is 10. And C, we have to choose our base. When you have a grid, you're going to find always find your base on the line. So we count 1, 2 as our base. The height, we're not going to use the slanted lines. We're going to find a perpendicular line that goes between this base and the opposite line. So the base is here. That's our base. So we're going to count 1, 2, 3, 4, because you'll see this line goes between the two bases. So we have 1, 2, 3, 4. 4 times 2 is 8. So that area is 8. 8, 8, and 10. And there you have it. Area of parallelograms.